Thank you, Hema. My name is Sarath Kumar. I'm the Senior VP handling product management at Tejas Networks. So you heard Kumar give the blue sky high level view of where we think the technology is heading next 5 to 10 years, right? And I will come a little closer to the current day and then see where we are and what is in anvil and what kind of technologies exist for to head in the right direction, which is what we heard so far. Okay, so I will talk about the optical and broadband access technologies and what are the trends there. So the macro trends, I think again this is a little bit of a probably a repetition, so I'll be very quick on it. One, of course, we have seen there is a ubiquitous broadband. There is a fairly huge demand for the broadband connections, especially accelerated due to COVID. Um, and then the second one is really the advent of 5G and 4G. Now, what does that mean for a network? You need cells which are much smaller. So the number of cell sites that you need to have to get this very high capacity coverage is significantly larger than what we are seeing with 2G and 3G. So the densification of cell sites or cells implies that your optical network needs to now extend. And then with the 5G rolling out, that's going to make things even worse. So there needs to be a lot more fiber going, far deeper into these locations. And the third one is, of course, there is a data explosion in the optical part of the network, because whatever data growth that's happening in the 5G or a wide access, that translates into the data explosion in the optical network. So we look at the micro details, get into each of these in a little more detail in the subsequent slides. And the last one is the enterprise modernization. Okay, so this is where there is a certain direction we want to head with a lot of digital transformation projects that are happening across the globe in pretty much all the large organizations. And then there's also cloud migration that is happening. But when you also need to take care of the legacy, and also where we are today. So how do you take care of all those constraints, especially in the telecom networks, for facilitating that modernization? Okay. First, let's look at the broadband. I think a few years ago there were many competing access technologies: the DSL, the cable, the point-to-point, as well as the PON, FTTX networks. Now, what we see now is fiber to the home, FTTX, rapidly replacing DSL and cable. So this is the dominant technology today, and it's going to eat up more and more of this. With many of these countries actually retiring the copper network that is in place today, because the cost of maintenance is quite high, and replace that with the FTTX. And average broadband speed is expected to triple in 3 to 5 years. If you look at the bottom slide here, you can see that the 10 gig PON that is actually going to take off right now. In several countries there's a quite a bit of uptake. I mean, of course, it has not come to India yet. I mean, we are still in the initial stages. But if you look at globally, there is so 10 gig is beginning to take off, and I'll talk about some of those reasons a little later. And then as we go into 2024, so that becomes a more dominant version of FTTX. And symmetric 10 gig PON is used not just for the home connectivity, the residential connectivity, but it's also opening up new markets for service providers. There's a lot of focus on how can I provide cost-effective connectivity to the small businesses and campuses, and also in addition to the wireless backhaul that Kumar did talk about earlier on. And then, of course, this actually implies a lot of enhancements to the PON to make it aligned with the requirements, to meet the requirements of the enterprises and 5G. I'll talk about that a little later. And another big initiatives that are happening worldwide is the governments are actually prioritizing the broadband investment, and they are looking at this as a way to bridge the urban-rural divide. And you heard the the IT minister announced that he's going to spend, there's going to be 20,000 crore investment. And again, it's primarily dominated by how can we provide e-government services and also e-health and of course e-commerce and other services, similar services, electronic services, the rural community. So there's a lot of investments that are being facilitated by governments. It's not just in India. So there is also the RDOF in the US and even in the UK market, many European countries, Australia. There are many countries we are actually investing a lot on the PON to bridge this gap, the rural-urban divide. Okay, so these are the key trends. Now we look at what does that mean to the current, the way that the service providers offer today, and also the kind of networks that they have. See, first thing is this is, as I said, this is going beyond the PON is going beyond the residential. So, and there is a lot of enhancements to the technology in terms of the providing carrier grade features and ring protection mechanisms, and also higher speeds with a 10 gig PON, so that you can actually meet the higher capacity requirements and also mission critical applications, right? One is the speed, the other is the resiliency and the QoS kind of requirements that are mandated by these. So PON technologies and networks are also evolving to provide this. And then of course, right, there is a way to, how can a service provider who is thinking of residential services today, maybe with a simple GPON, how can they evolve to a network that also supports 10 gig PON beyond? So there is combo PON technologies which are available, which actually makes it very seamless upgrade in future to these higher capacity PON technologies. And the third one is for a flexibility in connectivity options, because there are areas even in the urban, even in the urban cities, right? There are areas where you cannot draw fiber easily, right? And there could be the right-of-way restrictions or other constraints. So there are some enhancements made to the fixed wireless access. Use that as an alternative to provide even dense urban areas as well as the rural areas, especially where deploying fiber and FTTX technologies become a little more expensive, especially if you're looking at the last mile access, right? So these are the key changes. Now I'll get a little more detail into each of these. So first one is, what are the things that make GPON relevant for business services? So first thing you need to take care of is really the protection that it can offer. See, GPON typically the way it is deployed today is a tree. You go to a splitter and then you split and you connect all the homes, right? Whatever you see in the red is typically the network that is deployed. But there are protection mechanisms available where you can actually build an alternate tree, right? So again, this is one simple example of a tree-based architecture which is dual home to two different OLTs. But in principle, you can also actually build a ring with this same architecture, so that and then you can provide protection so that any one part of the ring is cut, you can actually do a switching in 50 milliseconds. And so that is the most important part of these business services. One, the offering the resiliency, and of course, there is also a lot of other features that need to be added, like SLA monitoring. And so I think that's what makes PON relevant for business GPON. And this is just one of the mechanisms, as I mentioned, that there are dual fiber plant. And this is, of course, the ideal if somebody is, say, building a network as a greenfield network, but somebody already has a network. Say, for example, this say green network. Now he wants to add the protection to this. So you can simply connect it to the splitter, right? So this, of course, provides slightly lesser resiliency because it's only in this feeder, what is called the feeder layer, you have resiliency. If there is a cut here, then there is then you don't, it's not protected, right? This last mile, what is called the distribution layer, and this is not protected. But this is useful, for example, if there are a lot of buildings, right? Say, for example, one building with the 100+ apartments. So you could actually think of splitter going all the way, and this is where the fiber cut is most likely until you reach the basement of the building. From there, you just distribute it using this, right? So there are some areas for industrial parks, so on, where this is relevant, and it becomes a very inexpensive solution compared to the earlier one. Okay, so this is one of the enhancements that are made to GPON, these two. Now I'm looking at the network side, right? So access side is on this side, right? There is, and then I look at the NNI towards the network. So here I just describe one simple protection mechanism that we have used quite widely. It's called OpenERPS. So there is an incumbent IP cloud, right? It could be IP, it could be IP MPLS, any of the technologies. So we just connect with one fiber here, and we build a open ring, right? So that basically means that we don't need any specific feature support here to provide this dual homing. And then whenever there is a fiber cut, right? So green is the original path. If there's a fiber cut there, it automatically switches to the protection path, and all this can happen in 50 milliseconds, right? So this is on the network side. So I mentioned two types of protection on the access side, type B and type C, and on the aggregate side, I just showed OpenERPS, but there could be many other technologies like IP or MPLS that are alternatives. But this is a simple layer 2 technology which is quite widely used. And the next one is an upgrade from when you are deploying, or a service provider is deploying GPON for initial deployments. Now the question is, now how do you enhance the network to be XGS-PON capable when that comes up, right? So it's already started taking off this year, and it's a matter of time before it's deployed even in India. So there we have something called a combo PON, right? Basically what you're doing is sending both these signals at the same time, GPON and XGS-PON at the same time. And then at the customer prem, you decide whether you want a GPON ONT or you want an XGS-PON ONT, right? So because these ONTs are, of course, residential ONTs are quite inexpensive with a 2.5 gig, but you want higher capacities for some customers ask for, say, for example, a gig and beyond rates, right? Maybe because they have a Soho, or they're running some enterprise at home, and XGS-PON could be useful there. And also business services, right? So here I mentioned that you can also think of offering protection for these enterprises, okay? So there is a way to build this. So all you need to do is make sure that you deploy the right kind of cards at the hub location. Initial deployment could all be GPON, right? And only when the customer asks for high bandwidth, so you just give him a XGS-PON, right? So that's, of course, you need to pay a little incremental cost here, but cost of the ONTs is what dominates a network. And in fact, this was also used as a good entry strategy for many of the small players. For example, in Europe, they said, okay, there is a lot of incumbents providing GPON services. Now, how can I differentiate? So they actually went and started with XGS-PON. In fact, we heard from Swisscom, one of the recent. So they were mentioning that the reason that they had to upgrade the network is because they saw a lot of competition from a smaller player coming up with quick XGS-PON solutions and upgrading, right? So there's an opportunity for new players to actually invest in XGS-PON, and also for incumbents to upgrade the networks to support GPON, XGS-PON, and also and of course they can also go to NG-PON2 and HS-PON technologies. So the standards are quite nicely defined, so that this is all an incremental investment and they can all coexist. Okay. Now the last one on this access layer is really using wireless, because there could be many areas which are non-fiberized, right? Even in, as I said, even in the urban areas, probably because it could be expensive or it could take time. In which case, the fixed wireless access based on LTE, for example, could be a good option. To initially, it could be that you provide very quick connectivity, because wireless can be brought up in no time. So initial connectivity, as soon as the customer comes, can be based on the fixed wireless, and then the service provider could take time to actually draw fiber to that location, and then in which case, after that, he can actually switch from the fixed wireless to the fiber connection, offering even higher bandwidths, right? That's one. And as I mentioned, there is a lot of action from the governments trying to provide the rural connectivity. And remote areas, this is a fairly inexpensive way to expand, especially for the last mile connectivity, when it's a small village, and a few tens or hundreds of homes. it might be cheaper or easier to actually provide that connectivity with a wireless option than reach out to the homes with fiber. And so we have a product which actually supports all these technologies, so that once it is deployed, it gives the option of all these upgrades, right? It can be GPON going to XGS-PON, it can be the fixed wireless, or even the Ethernet, right? So that actually, because it's one single equipment, the service providers don't need to think about what options need to be exercised where, and it also results in our calculations show that it can actually show for 49% TCO savings. Okay. I'll go to the second topic, which is the advent of 5G and cellular densification, and what is the impact that it is having on the backhaul networks today, right? So this one shows that in probably by 2025 you're going to have 1.8 billion connections. This is from GSMA. So basically, they expect that 20% of the connections would be on 5G, and the left one is a small cells, right? This is based on the 4G. You can also see that this is also expanding, quite rapidly. There's a fairly steep growth here, and and all of these require the cell sizes to be small, and so we need to find effective ways to actually build the backhaul network, because these are all high capacity. And you cannot, it's not very, the capacity of RF to match these wireless speeds is quite limited. And so what we expect is, in fact, the data says that from Omdia says that 74% of the wireless backhaul is expected to be in optical fiber by 2024. So there's a lot of fiber connectivity that is happening. Now the question is, what is the most inexpensive, the best way to expand that, right? So that is one of the challenges. And the second one is, although there is a huge amount of growth in the 5G connections, I mean, you look at sub-Saharan Africa, look at the MENA market, right? So what show here is that there is this 3% is the penetration that is expected in sub-Saharan Africa in 2025, right? And then 27% on 4G. Okay. Now, of course, it is what is shown inside circle is 29. So this is growing from 10% to 27%, right? And then of course, this is only 3%. And if you look at MENA, for example, what is interesting to note is currently the 3G traffic, which is shown here in 3G traffic that is shown here is 40%, and it's 36% here. But most importantly, interestingly, right, there is still quite a bit of 2G and 3G existing even in 2025. Look at this, and it's a fairly 46% is still on 2G and 3G. So although we are heading towards a lot of 5G, 2G and 3G will continue to persist in developing markets. So all the technologies that we consider have to take care of how can I support this while supporting the legacy, so that I can actually transform my network and without leaving out all these legacy requirements, which are still quite dominant. Okay, and so this is the point that I was saying. We have to ensure that there's a backward compatibility, and there has to be cost-effective cell site densification. And the best way to reach out this is to see if we can actually use the ubiquitous FTTX network. Right, there is huge deployments happening on the fiber to the home, and that is where the seamless upgrade to the XPON 10G and 50G PON and also NG PON2 technologies, they come in really handy, because this network is there everywhere. All you need to is to make sure that you upgrade this, and that can actually meet the 5G requirements. And of course, it brings in the timing distribution and also the resiliency and those aspects, but that can be addressed, right? That's not a big deal, right? And another important thing is that when the investments on the backhaul infrastructure are very high, so the best way to address that is see if we can build the shared backhaul. Okay, and how do we build a shared backhaul? Of course, one technology is OTN, and why I mentioned OTN is simply because it actually creates very clean partition of the bandwidth, the high capacity lambdas, right? That can be shared between multiple operators, and most importantly, you can also create different timing domains, right? Each of these operators, which is actually sharing the backhaul, they can have their own timing and synchronization domain. Okay, Of course, there are also other technologies which are evolving, right? Like PTN with the TSN, time sensitive networking, and so on, which are also designed to meet some of these requirements. But this seems like one of the very good options for this shared backhaul infrastructure. Now, this one just shows a network that you can actually build a typical PTN and OTN network, and without leaving out any of the 2G, 3G connectivity. So that basically, what does it require? What it requires is that this equipment should be capable of circuit emulation, one thing, right? Because they are PDH technology, you need to emulate the circuit and then carry it over it. And most importantly, you should be able to have efficient aggregation here, so that hundreds of these E1s can be aggregated and given on high-speed interfaces. So you minimize the number of connect points to the legacy, right? So you need both of these. So this is something that we have invested quite a bit, so we can actually support this kind of migration in our equipment. And the next one is the small cell connectivity. So there are multiple options again, right? You can actually deploy an XGS-PON as is, right? Like a tree structure, that is one. Because it provides a very cost-effective backhaul for small cells. And of course, as you go beyond 5G, and if there is a high capacity requirements, then OTN is also undergoing a lot of enhancements to make it suitable for the 5G kind of technologies, especially the stringent latencies and timing and synchronization. So there are multiple options, and there is and these are again, there's a OTN is an option, XGS-PON is an option, and again resilient XGS-PON with many variants is also another good way to extend this. So what you are doing here is leveraging the cost effectiveness of these ONUs in providing the small cell backhaul. Okay. So this is a slide on the shared backhaul. So it's useful not just when multiple mobile network operator, so they would want to have a slice each. So they would want to slice the network. So it could be PTN or it could be OTN. It's a wholesale network that is supported by these. Again, multiple technologies exist for this. And then another important aspect of this slicing, especially from the transport perspective, is being able to service these different applications, EMBB, MMTC, and all the 5G applications, so that you can have. And this is a prerequisite. Of course, slicing goes far beyond transport, but this is a support that is required from transport to be able to set up these slices with the given QoS guarantees, and also in a way that it can be automatically provisioned, right? So that's the aspect that is addressed by slicing. These are two different applications of slicing. One is the backhaul infrastructure sharing, and the second one is slicing across multiple services. Okay. So this is looking at the trends in building the optical layer. I mean, you can clearly see. So basically, this one is actually showing the revenue by each of the data rates actually, right? So this is 100 gig. So right now, 100 gig is at a very attractive price points, right? So it's used quite a bit. But then as 200 gig also takes off, it becomes more cost effective. So you can see 200 gig taking off here, right? Of course, what is noticeable is the way that the growth of 400 gig plus. So this is again becoming mainstream now. The technologies which are coming with 400 gig, that is actually making it very cost effective. So this is expected to take off in the next year or so. And of course, there's a lot of 100 gig deployments. It's moving to the metro, but I think the cost points of this are going down significantly. So you'll see the revenue is falling. But overall, you see the optical market is also growing simply to service all the demand, right? And this slide, this chart actually shows which are these applications which are actually taking up a lot of the bandwidth, right? As you can see, right? I mean, there is the highest demand one, right? Or the highest bandwidth hogger, if I may say, is actually the social video, right? All the video forwards that we get on WhatsApp. So that's what is the dominating thing. And next one is advertiser backed videos, where you watch a videos, but you have to look at ads, and it's provided for free, right? Because they are supported by the ads, but those are offered for free. And OTT is the one which is actually taking the third spot, right? I think especially COVID times, most of the entertainment is really happening in the OTT platforms. But so that's, you see a big jump here, and that continues to grow beyond. Okay, so these are some of the trends, and of course this requires some innovative solutions, so which can lower the cost per bit. And so what are the things that we can do, right? First thing is to make sure that there's no stranded bandwidth in the optical layer, right? And second thing is to see what is the most efficient way to use the current infrastructure that is already deployed, right? Now to optimally utilize the current bandwidth, one of the simplest ways is to introduce OTN switching. I'll get to the next slide, which actually shows this OTN switching, especially in the access. I think in the core and aggregation layer, OTN switching is used, but in what we call a micro OTN, so that makes a very efficient use of the bandwidth available in the access, right? And in terms of efficient use of the network assets, there are many technologies available, single fiber solutions, using alien wavelengths, because the infrastructure might have been built for lower capacity lambdas, but you can use this technology to actually drive higher capacity wavelengths. And also, as I said, there is the 400 ZR and ZR plus. So these are now released by the standards, and the price points are expected to be at a level that it's really going to take off. And another one is the pay as you grow architecture. So there's a lot of growth that is happening in this part of the network. Now the question is, what kind of technologies are available which enable one to start from some point and then keep growing as the bandwidth grows. Okay, and so this is a paper that was written in IEEE Communications magazine that actually compares the effect of WDM with Muxponder versus a WDM with OTN switching, right? So this is the traffic. What they did is they actually did a network planning for a pan-European network operator based on some 5-year traffic forecast, right? So they have taken some traffic, and this is a traffic volume, some city traffic during a period, 1, 2, 3, 4, 5 years, right? And city traffic is this, data center traffic, international traffic. So they made some traffic assumptions, and they had a network that is take an incumbent network. And what they did is, what would be the design if I built it with only WDM only, which is gray, and then if with the Muxponders, or a WDM with switching, right? So, and then they plotted how many lambdas would be required in each year, and then what would be the utilization of these lambdas, right? So some of the key results that they observed is that when they use the OTN switching in this layer, so that actually makes it 30% more efficient in terms of the number of lambdas, right? Now, how are they able to carry the same traffic with a 30% less lambdas? That is by packing the lambdas more efficiently, right? So that's what the benefits of OTN switching provides. So they realize that network bandwidth efficiency with this grooming, you can go up to 90%. So this is what I was talking about, sweating the assets and making sure that whatever is deployed, lambdas are deployed, are efficiently used. So OTN switching has its own role to play, right? So I think we just need to figure out or understand, which are the scenarios and make sure that, we design appropriately, okay? So again, right, so this is also showing what is the role of OTN transport versus what is the fraction of OTN transport revenues versus OTN switching revenues. Switching revenues are mentioned here, right? This is a transport revenue. So there is definite growth that is expected, and people are realizing the value of this, right? And what we show here is a sub-tera OTN switch. So there are some very compact products that are available, which are very, very cost effective in building this OTN in the access layer. So that makes it an efficient way to groom the traffic and also offload some of the traffic. Say, for example, some of the enterprises which are offering very high capacity, are requesting very high capacity connectivity, and point to point, one simplest way is to just give a sub lambda to that particular user, right, using OTN, and you could offer the same thing with a higher layer, say for example router based technologies, but turns out that for high capacities this actually is a very efficient way to a very cost effective way to provide that enterprise connectivity, okay? And of course, in the OTN in the core, right? Of course, this is true when in the access. So there is an OTN bypass, so it actually minimizes the router ports while providing the the protection switching with, and that actually reduces the capex, right? We have done multiple case studies on this, and this is efficiently mixing the way that network is built with enough grooming at a ROADM layer, at a OTN layer, and and also using the packet, whether it's MPLS-TP or IP-MPLS. By efficiently mixing, you can build optimal networks that are highly efficiently used. And of course, as you go deeper, there is you need multi-tera OTN switches. Okay, and so this is another one that how to sweat the assets more. So especially there is a lot of legacy networks which are built, and here in this case there is a existing infrastructure that is actually built for 10 gig lambdas. Now you want to expand the capacities, you can actually use the alien lambdas, and you can actually carry 100 gig and 200 gigs on this, which without any guard band, right? So this actually makes sure that you can actually mix the legacy optical layer with the most recent developments with the coherent technology and drive higher capacity lambdas. Okay. And the next one is again single fiber. This is again, there is as more and more, as the bandwidth grows, there are many places you are running out of fiber, and so this gives another way that you can actually use a single strand of fiber, right? And then actually you can run your DWDM lambdas on top of that. And again, there are multiple ways to build this. There are some bidirectional CFPs that are available, or SFP plus that are available, or you can also do it at the cross connect layer, so that using the same optics, right, you can realize the single fiber operation with the interleaver unit, right? So again, there are multiple ways that you can design this network, but the bottom line is that, okay, can you actually minimize the usage of fiber, right? As the bandwidth grows in the access layer, and you need to pack in more and more capacities, you don't want to touch the fiber that is already laid in the ground. So this provides an elegant option for that, right? And of course, the other technology is 400 gig rates, which I already mentioned, right? 400 ZR plus allows you to go to extended distances, 500 kilometers, for example. Okay. So this is the DXC. And how do we? One of the problems that I mentioned is how do you scale the equipment capacities? So the spine and leaf architectures are well known in the data center space. So you can, what we have done is found a way to use a similar technology. So we built some building blocks, and then you can actually increase your DXC capacities, right, just by adding more and more of these hardware elements as needed, right? So this is what the class architecture, and that can scale up to multi-tera, right, up to 48 tera in the backbone. So this makes sure that on day one the deployments are done with a lower capacity boxes, which also take up a smaller amount of space, but as it's a pay as you grow architecture. And okay, last topic I was coming to is the enterprise services. I mean, if you look at it, enterprises are there is a lot of digital transformation and cloud migration that's happening, and you can clearly see that the port growth rate there is quite a bit happening in the if you're looking at 100 gigs are growing at a faster pace, right? Which means that this has become the currency now, especially for data centers and also the routers and so on, right? So there is a good bandwidth growth here. But what is interesting is that the TDM based lease lines are still not going away. I mean, this is one of the from Omdia report. Now they did a survey, asked people over the next 2 years, how do you expect your private WAN spending likely to change? And a lot of the people said, there is going to be an increase in TDM lease lines, right? So this is what I was talking about. Legacy TDM is not going away anytime soon. It has a long tail. This is what we see in pretty much all the networks that we are playing in, right? And so what are the ways to do that? One is that you build unified products which support Ethernet switching, routing, TDM, and legacy services, right? So all these capabilities can be integrated, which is what we have done. And then use secure wavelength services, right? So the security is becoming quite important, and you're seeing, right? I mean, even recently there is a lot of security issues across the utility networks in the US. So there is a lot more focus now on providing encrypted and high capacity connectivity services. And again, for creating tiered service offerings, because not every enterprise is the same. There are SMEs, there are medium enterprises, there are large enterprises, and there are multiple technologies that are available. I think one way to efficiently optimize the network is to combine these in a way that suits. And so that's where I think you should be looking for equipment which can actually make good use of this in offering creative tiered service offerings, right? And so this is one example of a utility network, how it is built typically. So there is they still have a lot of legacy RTUs with serial interfaces, and there are some PDH muxes that are there. And there is a traditional SDH, for example, traditional edge. It could be an SDH box, right? And then, but then there's a EPBX, which is carrying E1 T1s. So there's a voice traffic. Then there are IP routers. This is the traditional way that is built, and these are the critical networks running, critical traffic in the utilities, right? The SCADA networks and so on. So they are a little slow to adopt to change technologies and change something which is working very reliably. But some of the new technologies, for example, you can clearly see that it's actually, you take all these boxes and integrate into that, right? So basically you can have products which combine the IP routing and the low speed interfaces and support a lot of these through emulations, right? So this is the multi-service boxes, which actually makes the transformation a lot more seamless. So this one is basically offering enterprise services or a data center connectivity. As I said, there is a lot of requirement for encrypted services. So what I've shown here is some of the edge data centers which are connected to the web scale companies. So they come to the metro data center, they are groomed at this location and then handed over to the web scale companies, right? So these are this is where there's a grooming that is happening, and you can have encrypted lambdas, and this can be at a at a lambda level or a sub lambda level. Both are possible. And then of course high capacity OTN cross connect can actually make sure that you do the grooming and send the right traffic to the right web scale company. Okay, so this is just using OTN with encryption with a DXC, right? And so this is enterprise connectivity. As I said, there are small offices, home offices, and also a lot of work from home that is happening now, right? Many of us are connected like this, right? So this is a good technology. GPON quite simply makes the cut here, very inexpensive. For small and medium businesses, you would need something which you can actually run like a ring, and this can be ELAN services or right with a shared Ethernet basically. And then with the large corporations, they might ask for either a C 2.0 services, and they would like premium level of availability, SLAs, performance monitoring, troubleshooting, and so on, right? So this is for large enterprises, right? And as I mentioned earlier on, there is a lot of movement towards using GPON, XGS-PON even for this by making it resilient, right? So that is also happening. So one thing is we have invested a lot is in making this one box which actually meet all these requirements, so that can meet the whatever is the requirements from SOHO, small medium business, large enterprises, and so on. Okay, so this is another important aspect is this integration that's happening, so that makes it easy to build these kind of networks. Okay, and this is probably the last slide in this, which basically you can also use OTN layer to offer different kinds of services using, say, for example, GMPLS. It can be gold service, which is mission critical traffic with a guaranteed low latency, low jitter, no packet loss. And it can be silver traffic, which is slightly lesser in priority, but then it could be protected with the there's no guaranteed reserved bandwidth, but it can be you can look at rerouting in case of failures, or it can be bronze, which is home broadband traffic, right? So there are many ways that many different ways you can offer services over the same infrastructure, meeting the requirements of different applications. And okay, so that brings me to what are the takeaways, right? So there is a robust growth that's happening in whether it's in fiber and broadband, or it's a cloud adoption in enterprises, digital transformation, and that is putting a lot of pressure on the optical part of the network to increase capacities while optimizing the incumbent or existing infrastructure. And some of the broadband access technologies are evolving, GPON making it robust and high capacity, XGS-PON going up all the way to HS-PON, and also non-residential applications, which cover basically 4G and 5G backhaul, and also integration of fixed wireless in cases where there is not enough fiber for a last mile. And in the key optical technologies, efficient use of OTN switching, not just in the access micro OTN layer, but also in the aggregation and also architectures which enable you to pay as you grow, so that you don't need to invest huge amount of space and power and money on day one, and you can keep adding bandwidths as you can keep adding the new hardware as the bandwidth increases. And of course, DWDM technologies are also advancing to make higher capacity lambdas more affordable. Price per gig is actually going down with these new technologies, and they have also evolved to make sure that we can use the existing infrastructure very efficiently. And finally, sophisticated traffic management and a lot of software, a lot of intelligence. I've not covered a lot of it in this one, but there's a lot of software that is coming into this to make sure that you can get zero-touch provisioning and all those advanced capabilities, so that in future you can get this, self-healing networks. Okay, so that brings my talk to a close.
Thank you, Sarath, for the useful insights. So I can see that there is one question. So I'll just read out the question. Starlink is coming up with high-speed wireless internet. How will that affect telecom sector and Tejas Networks?
Yeah, I think these all these technologies, they complement each other. They all have a role to play. As I mentioned, there are areas where you have very high capacity fiber connectivity, and there are areas where you don't have enough of fiber connectivity, and you need to use wireless to reach out. And there are many technologies that are available. I mean, there's Wi-Fi 6, and there is as a fixed wireless, and some of them are licensed band, some of them unlicensed band. So I think you need to really see what is the efficient way, for efficient technology. For example, you can think of connecting using Wi-Fi 6 over a unlicensed band, but then it only gives a best effort service. On the other hand, even Kumar talked about some private wireless networks, which need high availability, and they're all built on licensed spectrum. So there's a role to play for every one of these technologies, and I think there is enough market, enough work for all of us to do. And the more players, that's good.